Welcome to today's lesson, and then today we are going to be discussing how to determine the readings using a Vernier caliper. So a Vernier caliper, basically, this is an instrument that is used to measure length. So a Vernier caliper basically looks like this, where you're having the Vernier scale down here, these numbers here, the numbers that are down here, this is the Vernier scale, and then this ruler looking thing, this is what we are calling the main scale. So now, to determine the readings on a Vernier caliper, there are few steps that a person has to follow and put into consideration. For example, we are having something like this, where we know to say, a question here is telling us to say, the diagram below shows a Vernier caliper. Then we are told that. Then now we are told to say, what is the reading? So we have to tell the reading from the Vernier caliper that we are given. So now, one thing that we need to understand here, we need to differentiate between the scales. So we know to say the top part here, this is what we are calling the main scale. And then the down part here, this is what we are calling the Vernier scale. This is what we are calling the Vernier scale. So now, to find the reading that is showing on the Vernier caliper, following, this is the main scale and this is the Vernier scale. Then the question is asking us to say, what is the reading on the Vernier caliper? So to find the reading here, we need to know to say we need to add, or rather find the sum of the main scale and the Vernier scale. So how do we obtain that? So to obtain the readings in the main scale there, so we need to say main scale reading. To obtain the readings in the main scale here, we need to get the value that is just before the what? The Vernier scale. Are we saying that on it? So we need to get the value that is just before the what? The Vernier scale. What do we mean? The point where the Vernier scale is starting is this point here. So this is the point where the Vernier scale is starting. So the point that we are going to get for the main scale is the point that is just before the Vernier scale, that one there. So if you can see, this point here is the point which is just coming before the Vernier scale comes in. So this point, how are we going to count that one? We know to say in the main scale, each unit is representing 0.1. So if we start from 3, this is going to be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, then 4. So meaning on the main scale there, each point is representing 0.1. So if we start from 3 now, going behind, we are going to say this is 2.9, 2.8, and this is 2.7. So in the main scale reading, our reading there, it is what? 2.70. The SI unit we are given there, it is millimeters. SI units are very important in natural science because they show what quantity you are obtaining, or the quantity that you are measuring. Then now, to show the reading in the Vernier scale, you need to pick that reading, or rather the point where the Vernier scale and the main scale are connected. So if you look at this one here, if we start from 0 here, we start counting 1, 2, 3. So if we look at 3 here, the readings are connected. The reading in the main scale is connected directly to the reading in the what? In the Vernier scale. So this will be our reading from the Vernier scale. So if we start, we know to say in the Vernier scale, 1 unit is equivalent to 1. So we are counting from 0, 1, 2, 3, 4, and 5. So meaning at the point where these two are connected, we know to say this is 0, 1, 2, and 3. But there is a condition there. Writing here the Vernier scale reading, we are not going to write 3 there. We are going to apply a condition where we say it will be 3 times 0.01. That is the condition. So meaning the reading that you obtain from the vernier scale, you have to multiply 0.01, 0.01. So if we multiply 3 times 0.01, we are going to get 0.03 millimeters. So we are going to put it there, where we are going to get 0.03 millimeters. All the time, the SI unit is very much important because it shows the unit, or rather the quantity that you are obtaining. Then when you reach there, we have to add the main scale and the vernier scale. So we start from this side when you are adding scientifically. So we say 0 plus 3, we get 3. 7 plus 0, we get 7 points. 2 plus 0, we get 2. The SI unit that we are given are millimeters. So meaning the reading for this one is what? 2.73 millimeters. 2.73 millimeters. So let's take another example. Okay. So we have another example there. This is an example that is taken from one of the past papers. So this question is telling us to say, figure B1.1 is a diagram showing the reading of the Vernier calipers. So as we can see from the diagram here, we are having 5 and 6. Between 5 and 6, we are having 10 units. So this 10 units, it simply means 1 unit is equivalent to 0.1. So from 0.1, 0.2 until we reach 6. Then if we check from 0 to 5 in the Vernier scale, we know to say we are having 5 units. So meaning 1 unit is equivalent to 1. Then now let's obtain our reading. So the first question there is telling us to say what is the reading shown? What is the reading shown on the what? The Vernier caliper. So to show the reading there, we know to say the reading will be the main scale reading and also the Vernier scale reading. From the previous example, we said when obtaining the reading in the main scale, you have to get the reading that is just before the Vernier scale. So the point that we are having just before the Vernier scale, this is 5.1, 0.2, 0.3. So we are having 5.1, 0.2, 0.3. This is the point that we are getting, that is just before the Vernier scale. So we are going to have 5.30. Then after obtaining our reading from the main scale, we need now to obtain the readings from the Vernier scale. So from the Vernier scale, we are going to get the reading where the main scale and the Vernier scale are in the same line. So if we come here, if we follow, we know to say this one and this one in the Vernier scale. So from the main scale and from the Vernier scale, they are connected in a straight line there. So meaning that is the point that we are getting from the Vernier scale. So if we come from 0 to be 0, 1, 2, and 3. So since in the Vernier scale it is 3, we are not going to write 3 there. No. We are going to apply the condition that we are supposed to follow. So meaning we are going to say 3 times 0.01. So if we say 3 times 0.01, we are going to get 0.03. And not forgetting the units, like we are always saying, the unit that we are given there are the centimeters, even there, the centimeters. Then after obtaining those ones, we can add the 2. Where now we are told, what is 0 plus 3? We get 3. 3 plus 0, we get 3 points. 5 plus 0, we get 5. The unit that we are given are the centimeters. So meaning the reading on that Vernier calipers there that we are having is 5.33 centimeters. But the question continues, and then it is asking us to say, what physical quantity does the Vernier calipers measure? So the physical quantity, like we said in the introduction, the Vernier calipers is used to measure length. So B, the Vernier calipers, it is used to measure length. But to be more precise on the type of length that it is going to measure, it will be measuring the diameter. So if you want to measure the length of a coin, you can put it here, then you adjust like that. You put a coin, then you adjust. You are going to measure the diameter of a coin. If you want to measure the internal diameter, maybe inside a bottle, you are going to use this side, where you are going to put inside the bottle, then you adjust, and then you get the readings from the vernier scale there, and also the main scale, which is on top here. So this vernier caliper, it is used to measure the length of different objects. Now, the last question is telling us to state the precautions. So, when using a vernier calipers, this one, there are certain precautions that you have to put into place. Or rather, when you are using any instrument in science, when you want to measure anything, there are precautions that you're supposed to put in place. And then in this case, when you are using a vernier caliper, the first precaution that you're supposed to put in place is that when you are about to start measuring, you have to make sure to say your instrument is at 0. So the first precaution there that you're talking about is that you have to 0 the instrument. You have to 0 the instrument. All the time you have to make sure to say your instrument is starting from 0 before you do any measurement. Then the second precaution there that we are going to take is that this vernier calipers, it was made by human beings. So the more you drop it, the more you are disturbing the accuracy of this instrument. So we are saying avoid dropping the instrument, because if we keep on dropping this instrument, if we are clumsy with the instrument, it will result into the instrument losing its accuracy. So it is advisable that we do not drop the instrument. Another precaution that we can add there is that this vernier caliper, as you can see, it moves. It has got moving parts. So it can move all the way up to there. It can also come to there. So in order to obtain a smooth movement of these moving parts here, we need to lubricate them. So lubricate the moving parts. So we have to lubricate the moving parts. We make sure to say these parts that are moving, we lubricate them nicely so that there is a smooth movement of all the parts that are there on the vernier caliper. Then to add one more for you, there is a common known precaution where they say dust the instrument. They say you have to dust the instrument using a clean, dry cloth. So we are saying you have to dust the instrument using a clean, dry cloth. So these and more are some of the precautions that you are supposed to take when you are using a vernier caliper. How you obtain the readings on the vernier caliper is the way we did it in the first example and here. And also this vernier caliper, we should not forget that it measures the length. So thank you for joining us for today. Make sure to tune in again next time where we'll be talking about the micrometer screw gauge. This is Mr. Okunde. Make sure to say you subscribe, you like, and you follow. See you next time.